Again, I'm super excited about this discussion now on tinyML for good, because I personally believe that tinyML has a lot of potential to make a significant social impact. And fundamentally, that's because unlike cloud-based ML technologies, tinyML is ultimately and intimately connected to the physical world. So basically, we collect the data where the data is produced, and then we can do a lot of actionable things there. So, and including social impact as well. And talking about this panel, I cannot think of a better person to lead this panel. Fran Baker, she leads Social Impact Innovation Group at ARM, and she's been doing this passionately for quite a while. And she was recognized, I think one of her recent recognition was the UN Global Compact SDG Pioneer for UK in 2020, last year. Congratulations, Fran, on this. And I think the stage is yours, and I'm really looking forward to this discussion, hopefully learning and contributing. Go ahead.
Thank you very much. And I appreciate that this is the last session of the day for everybody, so thank you for staying with us. As Evgeny mentioned, I lead social impact and innovation, and that's within the corporate sustainability function at ARM. And so I'm fortunate to work with many of our social impact partners like UNICEF, the Gates Foundation, conservation charities like Flora and Fauna International, as we try to innovate even for the hardest to reach. And so in my role, we're trying to explore how we can best connect our business capabilities with our societal responsibilities. And to distill down a few years worth of work into a few sentences, we're looking to decarbonize compute whilst close the digital divide. So driving down carbon emissions whilst driving up connectivity. It's a pleasure to be here today, and thank you for having us. A quick summary of what you can expect in this session. I'll give a brief overview of the global challenges. So we're really coming back out into the big picture challenges for this session today from a sustainability perspective. Quick run through of the objectives of the session. I'll then introduce you to our panelists and their experience of tinyML development, and then there'll be lots of time for our panelists to talk more about their experiences, problems they've encountered, and to also take plenty of questions from the audience. So please do use the Q&A function throughout. We'll be monitoring that and weaving that into our conversation where possible. So setting the scene, what are we talking about when we talk about for good? This is coming back out to that big picture perspective, and a good way to look at this and understand the global context and the challenges that, quite frankly, we as humanity are facing is through the Sustainable Development Goals. And so for a reminder for people who don't necessarily know what the goals are, in 2015, world leaders from all 193 member states of the United Nations agreed to these 17 interconnected goals. It's known as the 2030 Agenda for Sustainable Development. And the aim of this to-do list is to create a better world by 2030, ending poverty, fighting inequality, and urgently addressing the climate crisis. And behind these goals, there's 169 targets. Behind the targets, there's 232 indicators. And each of these targets and goals are used to measure progress towards reaching them. And you can really look at this as the world's largest to-do list. And increasingly, over the last few years, businesses and organizations are coordinating around the goals, where we're recognizing that you can't have healthy people on an unhealthy planet, just like you can't be a sustainable business in an unsustainable world. And this is important to the tinyML community because 70% of the targets that sit behind these goals can be directly affected by advanced technologies, which means that the tech sector has got a massive role to play in addressing some of the world's biggest challenges, not to mention the $12 trillion commercial opportunity available in unlocking them, and $2.1 trillion of that available for the tech sector. And yet, there's a tension between technology as the solution to environmental problems or as an exacerbating factor. There is the need to decarbonize our economies is in conflict with the processing needs and expectations of the world as more and more people come online, more and more demand for compute power. And so it's critical that sustainability factors are considered in the design and deployment of technology, as connectivity and device access become critical enablers for social and economic well-being. tinyML has got the potential to transform industries, to transform the environment, to transform society. And thanks to continuously improving technology and an engaged base of committed developers, we're seeing a huge variety of new use cases that haven't even been considered before. And we've heard a lot of those today. Things like sensors that can track crops for the presence of damaging insects, monitoring systems that track pollution and energy to make cities more efficient or sustainable, or healthcare monitors that track vital signs whilst maintaining privacy, low power, low cost, easy to use solutions, and networks of industry, research, and developer partners to bring them to life. And so the goal is for sustainability to be considered as a driver of technology innovation as opposed to an outcome, and for these goals to be a catalyst for sustainable innovation. And so for today's session, we're hoping to discuss what do we mean by tinyML for good. I've set the global context, but our panelists will be able to bring that to life for you a bit more. Why is it important? What defines such systems? And considering that as there's huge shifts currently underway in the computing market, how do we also consider the huge shifts that are happening for society and planet too? And finally, how can we as a tinyML community best help to accelerate the development of tinyML for good? So joining me today, we have a great lineup of speakers. I'll take a moment to introduce you to them. Tomas EDSÖ is a distinguished engineer in the ARM ML group in Sweden. He's the tech lead of the embedded EDSÖ micro MPU products and also works with the micro MPU roadmap, as well as being part of the tinyML EMEA committee. Gian IODICE is the tech and team lead for the ARM Compute Library. He's responsible for machine learning software performance optimizations on ARM processors and is also the organizer for the tinyML UK meetup. Rosemary, NALWANGA, Samson, Otieno and Marvin, OGORE are joining us from the African Centre of Excellence in IoT at the University of Rwanda. Rosemary is looking at tinyML-based precision agriculture for environmental conservation. Samson is the co-founder of Edge AI Solutions with his research interests in Edge AI inference for early predictions of COPD. And Marvin's a researcher working through a World Bank sponsorship implementing AI and ML solutions that are scalable and impact African societies and the world at large, focusing on water, sanitation and hygiene solutions. And we also have with us Gian JONGBOOM, who we just heard from, so I don't need to reintroduce him, but he's the CTO and co-founder of Edge Impulse. And finally, Ciira MAINA. Ciira is the lecturer in electrical engineering at Dedan Kimathi University of Technology in Nyeri in Kenya. And he's also a member of the organising committee for Data Science Africa, which is aiming to improve knowledge of machine learning in African countries. And he's currently working on several projects aimed at applying ML and IoT to problems relevant to the African context. And breathe. And so to kick off this conversation, I'll aim my first question to Tomas. Tomas, as the tech lead in the ML group at ARM and also being part of the tinyML EMEA committee, what does tinyML for good mean to you?
So thank you, Fran. So to begin with, I'd like to start by emphasizing how big of a question that is. And I will only focus on the things that are closest to me on this. So one of the aspects is, of course, that it's related to the application itself, what it's doing, that the intent is ethical and the use case is ethical. And you touched upon this with the global goals. And I'm sure the other panels will cover that part well, right? So I will focus on more the important aspects of the technical solution itself that realizes these applications. And I choose to emphasize that. And so to begin with that, we can have a look at the endpoint itself, the device, right? And for me, to realize a solution that is tinyML for good, it has to have a few important characteristics. And the main ones there, in my opinion, is privacy and sustainability. They have to enable that, right? So looking at the sustainability, that means the product should be energy efficient and being able to be built on cheap, small batteries or even no batteries and running on energy harvesting so that you don't need to replace frequent your batteries, right? But sustainability also means to have a solution which is flexible enough to stay in the environment for a long time so you can update it, to be flexible enough to stay relevant for a long time. So flexibility, I would say, also very important aspect of the product. And then privacy, I know it being touched by other speakers today, like Wolfgang from Infineon. Very important in a solution that you intend for good, that it stays for good, that the data stays safe, that there are no holes of security in the security of your product, right? That you cannot leak data and things like that. And privacy is actually also coupled with the capabilities of the solution. So having a very high energy efficiency such that you can enable high raw performance enables you to have the data staying on the device and not depend on the cloud. That's another really important aspect of the solution, and something that we're seeing being realized now with the hardware coming up. And then finally, I would say that is another really important aspect that maybe some other in the panel will bring up more, is actually related to building and maintaining the solutions themselves. So gathering all the data and maintaining it and training it has equally large or even larger problems with privacy and sustainability, in that the data centers are actually consuming large amounts of energy in order to train these models. So there's a lot of things to do on that side as well with the hardware and algorithms, and as you mentioned as well, the whole decarbonization of the industry as such and the data centers. So these are the aspects like energy efficiency, flexibility, security, and performance that I think of when trying to enable tinyML for good, and that's something that historically also has been very close to the heart of ARM.
Yeah, absolutely. Thank you, Tomas, for that. And I think that's the distinction in sustainability on whether we're thinking about the individual, the organization, the ecosystem, and the world. There's a thread that runs through all of it. So from a foundational technology perspective, how do we consider that? And then moving to Ciira, could you share with the audience your experience of tinyML development and the potential that you see for tinyML for good? I know that you've got many examples of those solutions that Tomas was referring to.
Yeah, thanks a lot, Fran. It's a pleasure to be on the panel. As you mentioned in your introduction, I am based in Nyeri in Kenya. And for those of you who've been lucky enough, like Gian, to have actually come to Nyeri, you'd have noticed that it's a very beautiful environment, pristine ecosystems. And as a researcher there, I actually teach electrical engineering. We've been looking at a lot of applications in environmental conservation. And so we've been working in areas like acoustic ecosystem monitoring. So what that means is just listening out to the environment and seeing and determining whether it's in a good state or not. And that actually relies on a lot of signal processing. And what we do in the beginning would be collect a lot of data. What we are applying tinyML to do is to try and collect the data in a smart way. So for example, if your device is always on and always recording, and then you have to process that data downstream, simple ML, like just, monitoring the energy and determining that you've actually got acoustic events. That's ML. I know a lot of people like the sexy ML, that is neural networks, but monitoring energy and determining that this is data worth keeping is an interesting application. So, and then of course you have the fancy ML with neural networks. Something else we are looking at is monitoring our rivers. So another thing in the environment is, these are sources of water, and we have IoT sensors spread out in various rivers in Kenya. And what I once attended a talk, and they said that we have an internet of broken things. So a lot of the data can be erroneous. I mean, not a lot. You hope that you're at least getting useful data, but you need to deal with anomalies, and dealing with them as close as possible to the sensors is a good application. So that's something we're also working on. Other things maybe I'll get to talk about later is applications in health. But in addition to that, one of the big things I'm interested in is capacity building. So my other role that you mentioned is organizing Data Science Africa, helping to do that. And we've had sessions where people are playing with SparkFun Edge devices to do keyword spotting. So to try and disseminate this knowledge of tinyML within the African ML community. So I think I'll stop there.
Yeah, the one thing that I want to add to Ciira's thing, like for me, I don't think EDSÖ would have existed if I wouldn't have been at Data Science Africa for a couple of years, because that's the first time I saw really kind of what the potential of ML and IT could do together, which is really awesome. Like Ciira and I were running through a field after a cow with a laptop in one hand and a Wi-Fi base station in another. So
I think Gian, in this case, you have to commit 50% of your revenues back to Africa then, as a recognition.
we do part of that. I'll come back to that. But if you're a corporate sponsor or something, you have some money left in a do good budget, consider sponsoring Data Science Africa, or just consider coming down next year to help out. For us, and I think for a lot of people in ARM, it was really pivotal moment. So I can only applaud that. So.
Absolutely, and that actually leads to a question I've got for you, Jan, which is around what kinds of challenges have you faced in deployment? And I think we've all heard of many examples from Data Science Africa. That I heard an interesting story about a cow a few years ago. I'm not sure if that's one to share here, but what sort of challenges have you faced in deployment through those experiences? And maybe Ciira could add to that.
Yeah, it's not really, it's a little bit ML related, but I think I went to Data Science the first time to DSA in 2017, and then back in 2018, 2019, last year, unfortunately, couldn't go because of COVID. We figured kind of like after running like workshops with people, and for the first time, we we're going to bring like a small ML component in here, and we always try to find kind of a use case that really helped people, right? Like a really local problem. For me, one of the cow problem, or the cow use case kind of came. I never imagined that a sick cow could be so expensive for a dairy farmer, or that actually wasting a semen sample is really expensive because it's, I think, $2 to $4. But that's not. I don't know. I don't think about cow semen every day. So talking to a farmer there is really interesting. So after 3 years, we kind of figured, okay, we've nailed it down. We know exactly what we need. We built our devices. We had Chris Tiles from ARM actually built really nice PCBs. We had gateways that we could actually use to get some data through. We had a couple of ideas of ML models that we wanted to build with the data. We get to the site and there's no power. Like literally everything we figured everything out. Now it's not there. Then I actually got sick. Like we had to figure out the power with the generator, and I got really, really sick, and we had to cancel that again. So not so much ML thing. I think for us, the biggest thing around deploying ML at the edge is that it's the thing that I think the guys from EMEA said a couple sessions ago. It's so easy to get to 98% of your use case, and its final 2% is really, 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 really hard. And do you have a nice way around it? No, not yet really. But I think as an industry, we need to grow up in that sense, much wider than in tinyML for good. But I think as an industry, we need to grow up and realize, okay, what do we actually need for this final part? What kind of operations do we need? Do we need, like Ciira says, do we need to know when a sensor is starting to malfunction? And how do we actually know that? When do we know when there's drift? And that's kind of stuff that we skip over easily. So I don't have the solution for that, but I do think it's an interesting discussion point.
If there's no more to add to that, I'm going to jump to Rosemary back onto the environmental conservation point. So Rosemary, your research has been looking at tinyML in the context of precision crop farming systems for environmental conservation, which sounds really interesting. Can you tell us a bit more about
that? Thank you so much. In reference to what Fran shared at the beginning of this session, something related to the Sustainable Development Goals. With this current research on crop farming, we focused on using tinyML-based solutions to increase agricultural production while promoting environmental conservation. With the current solutions that we have, there are a number of precision farming systems that help farmers to come up with more productivity in their yields so as to sustain the population that we have. And most of those solutions recommend farmers to use fertilizers as a remedy to poor soil fertility. Most of the solutions also use changing weather patterns. They are cloud-based, and we know with the cloud there are issues with latency and thus increasing costs. And most of the farmers in Africa are based in rural areas where there is no infrastructure, and thus there are connectivity issues. So with the tinyML, it comes in as a very good solution whereby we come up with those tiny models that we can deploy on edge devices, whereby a farmer has a device and they can have their inference done just at the edge, whereby they may not need so much the cloud, and hence they be solving the connectivity issues. With those tiny ML models that we come up with, since the inference is being done at that edge device, it helps farmers to do timely actions, whereby immediately after the sensor sensing what is going on, they can tell the farmer, do this in a timely manner. So we use the tinyML and come up with the models to predict the best crop that a farmer can grow in this context. Considering this crop that is being predicted, the farmer will not need the fertilizers because they're based on the real-time sensors picking data from the soil. So it will be helping in conserving the environment, it will be increasing productivity to the farmer, and then it will be reducing the costs, because since we are doing things at the edge, we will disregard the cloud, and thus costs are being reduced. With this, we use our edge impulse to train our models, and we also use the STM32 that has the ARM cortex, and these are the ones that are being used, and they are being helpful to us in coming up with these solutions to help farmers and hence sustainability to the environment. Thank you.
That's awesome. Thank you, Rosemary. I think as you were talking there, I was just thinking about the zero hunger global goal. And if you think that there's 815 million hungry people in the world, soil health degrading and a massive challenge for us to be able to feed everybody on the planet. We have enough resources, we have enough food, we have enough places to grow such crops, but we're not using that space efficiently. How can technology help to unblock some of the challenges there? I think really interested, especially considering the types of use cases that you're looking at and people that you're working with, and smallholder farmers producing the majority of the world's food. So taking it from the very specific to the big picture, I think that's a great description of the work that you're looking at. Marvin, you've described yourself as passionate about AI and ML solutions that impact African society. Can you share a bit more of the technical challenges that you face in your work on prediction of cholera in rural community water taps?
Thank you very much for this opportunity. So just allow me to give you context on what I was working on. So I'm working on cholera detection. This is disease detection. And you'll notice that from our research, cholera accounts for, in Africa, cholera accounts for 54% of the global disease burden. So we need to have a way to detect the disease effectively and in a timely manner in order to prevent an epidemiological crisis. So we are looking at how we can detect cholera at communal rural water taps. These are actually some of the main sources of water in rural areas in African settings. So we looked at the conventional devices that are used to detect cholera. And since we are looking at an African context, we are looking at resource constraints, and we are looking at the conventional techniques that require substrates that might be expensive. They require to be refilled. So as a solution to this, we decided to use Edge AI, as we're looking also at connectivity issues that are based in rural communities and rural infrastructure in Africa. So some of the technical challenges that arise in my context are there's very limited data in regards to because my research is based on physical chemical properties of water that are measured against a cholera cell count. So for you to get that data, you need to employ these expensive conventional techniques that are expensive, so you cannot do this as frequently as I'd like to do. So there was an issue with data, and as a solution, we looked at how we can synthetically generate data, that is looking at the trend of the existing data in order to generate more synthetic data that is following the trends of the already existing data. Another issue, technical challenge that I experienced was I was using Edge Impulse, and Edge Impulse provides you a way to actually have a graphical way to deploy neural networks. There's also an expert mode. But the objective was to have a very easy and scalable way to do this. But when we're looking at machine learning techniques that will be employed for low data sets, it will need machine learning expertise, which is one of the issues that we're trying to do away with. We're trying to look at how can you have someone with limited machine learning expertise having to deploy the same techniques on to be onboarded to the same use case. Another issue was that since we were simulating, that was one of the objectives we were doing, we're simulating on one of the platforms, and we were targeting ARM Cortex M4 microcontroller units devices. But the issue was that the simulation platform that we were using did not provide for a variety of other boards. So we were only able to simulate our use case on an STM32 device. So it did not provide access to boards like Arduino, which will be suitable. And the challenge with this is that when you look at African settings, when you're trying to acquire these boards, most of them give you access to Arduino. So this was another challenge, that the simulation platforms do not give us a leeway to scale to other devices that might be more accessible in African settings. Thank you.
Thanks very much for that, Marvin. I think there's a few nods coming from the other panelists there, so they might be able to jump in and answer some of the questions for you. But then thinking about the global context of that, I think the reason for your work is really powerful. If there's 850 or so million people living around the world without access to safe drinking water, it can be things that are taken for granted in different areas. When through our partners at UNICEF, we've learned that diseases that are linked to unsafe water are one of the leading causes of death in under 5s around the world. And it's really difficult to get your head around the scale of that kind of a challenge. So I think it's amazing what you're working on and the kind of technical challenges that you're facing. I hope people on this call are able to help you unblock. Samson, your experience has been, you've been working on early health predictions. Can you share how tinyML can be applied to preventative or personalized healthcare solutions?
Thank you very much. Healthcare is also one of the, in fact, it's number 3 among the Sustainable Development Goals. And one thing that is very important when it comes to healthcare is early prediction of diseases. So when diseases are predicted early, you can be able to help avoid complications. And most of the times, people may have certain diseases and they wait for symptoms before they are able to go to hospitals to be able to experience and take some of the tests. So in Africa, the challenge that we have is that the process, when you go to, let's say, a healthcare facility, you are taken through a long process, a number of tests before they are able to diagnose what you're suffering from. Also, expertise are very few, so you may find even people are taking long hours just lining up to see a doctor. And even in some areas, accessing hospitals is a challenge. And so we thought of having a home-based kit that anybody can be able to use from home to be able to check and see the health status and to be able to detect different diseases. And we are looking at using non-invasive methods, which is where the world is moving towards, to be able to detect diseases. Look how we can be able to detect respiratory diseases from exhaled breath. And so we thought of, looked at what is being offered around the world. And there are some few solutions from the developing world that are more of cloud-based. Now, applying cloud-based solutions in Africa is also a challenge. And so we thought of using tinyML. The main reason for this is to enable us to be able to have solutions and to be able to inference at the edge on our edge devices, and basically to be able to overcome the limits of connectivity in different places, so that when anybody is using such devices, it doesn't matter where they are and they're able to diagnose themselves. There are also energy challenges that we are able to save energy, and also issues to do with privacy and security in healthcare is a concern all world over. So tinyML came in handy to be able to help us to be able to do this. And so we came up with a group to look at what are the tool sets that we are able to have and we can be able to use to help us to be able to achieve this. And so we identified different open data sets that we can be able to use. Something that is good to note is that when we were looking at these data sets, we found out that most of the data sets are more from the European world. And I don't, there has been a debate even with COVID that the effect on Africans and Europeans is a little bit different. So looking at that data set, then it's also good to have something that is also applicable to Africans. So collecting data is also something that will be of importance. And so once we came up with this data set, we identified different tool sets. I'm glad Gian is here. We are able to identify edge impulse as one of the tool sets that we were using. And then also ARM Cortex boards also come in handy, and we are able to simulate. And the other challenge that we had is supply of different boards in Africa. So we have to order them from Europe most of the time. So maybe ARM Cortex and other board suppliers should think of collaborating with Africans to be able to ensure that we have access to these boards and be able to come up with some of the solutions. So once we came up with this, we developed different models, and that we can be able to inference and detect if somebody has a disease or not from home at any time, and then they're able to get that. This is scalable to other diseases, and also even applying different techniques. Apart from exhaled breath, there are also other techniques that can be applied to ensure that we are able to solve health problems that people may be able to exist, to be able to experience in different places. And so for me, when I look at tinyML for good in healthcare, it is something that is there, and we need to have lots of collaborations. I'm glad that there is a little bit of collaboration with Africa, but also we also need more collaborations. If we can have, let's say, ARM Cortex, a branch in Rwanda, or working with some of these centers, Edge Impulse Africa chapter. So we are able to collaborate, because use cases of Africans are somehow different. Because if you take a solution from Europe, bring it to Africa directly, you find it doesn't work the way you expect. So that such collaborations will be very good to be able to help us and to ensure that we are able to use this. I think that's what I can share, and then we can discuss more as we go along.
That's great. Thank you, Samson. Yeah, I think you touched on the broader trend of moving more towards precision medicine and the importance of early diagnosis for any disease. The ongoing privacy and security considerations, particularly around access to people's healthcare data, but then most importantly, understanding and developing technology that's situationally or regionally appropriate. So design with the user, it's kind of the, in terms of technology design principles, ensure that you have the people that are going to be using the technology designing or in the room when it's being designed. So thank you very much for your comments, and I'm sure that we'll pick that up again in a bit more detail shortly, although I do know that we are slightly late starting and are also running over. So I'm going to ask Gianmarco a question, and then we've definitely had something from everybody, and then those of you who would like to stay on and carry on the conversation are more than welcome. So Gianmarco, you're responsible for the ML software performance optimizations on ARM processors. What kinds of things do you want to hear about from the community, or what kind of challenges would you like to understand more about?
Okay, so thanks a lot, Fran. And yes, it is absolutely a pleasure to join this panel. And it is a pleasure because we have the opportunity to learn from people that are working on tinyML applications, what the challenges are, and also the solutions at the same time. Yes, as Fran said, I'm working on performance optimizations, and there are quite a lot of things I like to learn from the people that attend this panel about data, about the boards used. But in particular, there is one aspect I like to learn more from an engineering perspective. And I like to learn more about the challenges and solutions to extend the lifetime of battery-powered applications. Because I can imagine that most of the applications that we're talking about are battery-powered because they don't have powered sockets nearby. And so I like to understand what kind of challenges and also solutions in terms of software, hardware. Just to give an example, for instance, in terms of software solution, what kind of methodologies we use for sampling the data from sensors, or in terms of hardware, what kind of hardware models we use, or hardware components we use for energy harvesting, and the implication also on the cost of this, because those are important aspects along with other important challenges that I like to learn from this panel. Performance is for sure one component to extend the lifetime of the system. Of course, it's not everything. The other aspect that I like to learn from this session is, do we actually have all the necessary tools and know-how to extend or to solve this problem? And if not, do we need as a community to do something to make this problem simpler? I know that probably is a huge task, but is there something that we can do together as a community to provide tools and support for solving this kind of problem? This is more or less what I'd like to hear from today's session.
Yes.
Yeah.
So,
and just to say that there is a survey in the chat function, so if people are able and willing to complete that, that would be much appreciated. Sorry, Tomas, over to you.
Well, yeah, Gian, Marco. So I have a set of questions which sort of align well with your questions there, but maybe sort of an attempt to question and answer at the same time, right? So I picked up during the day, sensors being a problem. That's probably something that is needed to really, improvements in sensors. We heard from Infineon. So is that something we will be helping with by more cheap, reliable, different kinds of sensor? I can imagine even experimental sensors, measure. I mean, if you have a true machine learning solution, they don't have to measure anything that makes much sense, at least at first, right? So just a brainstorming topic. So have sensors that you can learn from, right? Other things, yeah. So some public data sets, and that you can, for all more types of sensors. Maybe that is something that a sensor developer could be great if there was some kind of example data, together with sensors that you could use for learning purposes, or characteristics you can use and things like that. Because it seems to me the data is a big problem here. So I said, yeah, I'm throwing that out there for you to sort of brainstorm around.
My personal experience with this, and I at least Ciira will probably second me here, is I don't even think it's the sensors themselves, but it's rather the supply chain. It's, there's a lot of stuff that we take, like if I want, I don't know, like random environmental sensor, I go to DigiKey and I have it tomorrow. If we want to do the same thing, we do it in Tanzania, it takes 3 months and me stealing a box out of the airport to actually get those sensors to the university. So the thing that there's something that I would love for the community to kind of go behind is say, hey, there is a certain platform like AudioMod, I think is fucking awesome. We have a cool device, brilliant. Let's just standardize on that. Let's make sure that our ML part works on that, and then work on getting the supply chain actually to run there. I think it's still crazy. I can't buy a normal camera trap and run an ML model on it right now. Why is there not a camera trap that is, just working and we can just get them to Africa easily? Why is the audio mod just still in a data collection device and not also a classification device? I think that is a much easier first step.
If I can jump in, Jan, I think going back to also a few things that were mentioned earlier about some of the challenges, like in energy harvesting. I think personally, my own experience being in Kenya, which straddles the equator, is that we also need to look at our problems in our context and understand that, you know, the sun is here shining. We can have, you know, if you build your systems, you don't act like you're not within, you know, a region on the equator and have all this energy from the sun. So building systems that are also energy harvesting and incorporating them, and it's not just purely battery powered, so it's also recharging, and you can leave these devices out, and also allows you, for example, to use devices with a lot more compute perhaps, and you just need to be smart about things like scheduling and things like that. So for example, as we, in addition to the audio mod, which is also collecting a lot of audio, is augmenting the Raspberry Pi to be able to do the data collection, classification, and so that you can have a smarter device. So I think we also need to adapt to our current, I mean, our conditions. So, and also take advantage of, you know, the resources that we have, and not just necessarily say that, okay, these things are all battery powered, and I mean, they end up having to now keep on replacing batteries. And yet we can use and engineer systems which, you know, essentially live forever. That's been one of my things in the lab that we're working.
And yes, and I think that could be, I mean, from a hardware perspective, creating a board which already has an energy harvesting solution, probably, I mean, it simplifies the problem. And the other thing is, do we think, for instance, that tinyML could actually also solve the problem of extending the lifetime of this product? I would like to give an example, because I believe if we have, let's say, hundreds of these tiny devices, that they need to communicate with each other, because they need to collect the data, and probably they need also to share this data with the host. Can tinyML play a role to reduce the transmissions, or anyway improve the communication between the devices, and then extend the lifetime of the network at the end? Because at the end we like
easily. Like, it's an actual real customer case came up today, not completely related to Africa, but customer has a GPS sensor on, or has a GPS chip on a sensor. They're currently spending 80% of their budget trying to find a GPS fix when the device is indoors, when it's not going to find anything. So they're going to deploy a ML algorithm based on environmental sensors. And the only thing you need to know is, am I very sure that I'm indoor? Then I don't send anything. Bam, device is twice the lifetime. Really simple use case, very small model. Probably don't even need, you know, a neural network. But you know, ups the lifetime of the device very quickly. I think there's a lot of these kind of quick wins that we can still do.
Yes, so there was this question on what we can do from a hardware side to reduce energy, and I actually, even though I do the hardware, I think hardware often has a lot of capabilities already to shut power off and to wake up efficiently and sleep, etc. So I actually think this is more of a software and sort of a high-level application thinking that you need to take the major wins. I would agree on that. Then obviously hardware gets more and more efficient, and I think we're at the point in time where ML capabilities are improving much faster than other technologies because of the innovative nature of it, right? So that will happen. You know, the ML workload itself will become more and more efficient. But then looking at, again, from application side of view, I don't think that is where you will have these big wins. So it needs clever applications to actually make use of all the energy saving mechanisms that are already there.
And I agree with you, because, I mean, if we take an example, for instance, adaptive sampling. So probably we don't need to run tinyML all the time. So, I mean, it depends also which physical quantity we are dealing with. in simple terms. If you are dealing with the temperature of the environment, probably it's not going to change in a few minutes. Probably it's going to take more than 10 minutes, let's say, and adaptive sampling. So these are all problems on the software side. So a combination of software and hardware probably can extend definitely the lifetime of the sensor or the network in general.
Now I would argue as a sustainable...
Yes, a quick chip in also.
Go ahead, Samson, you go first.
Yes. Okay, thank you. First, when we were talking about data, I think it was Tomas who was saying that sensor providers is having to have open data sets. As you know that ordering equipment take time in Africa. So if you can get data that you are using to maybe simulate as you wait for the equipment to come, you can do something, and so when you get the equipment, you already have a model that you can deploy, other than waiting for an equipment that you will have to use to collect data, something that you could have done in a short period, so then you lengthen the time. And also when it comes now to saving of energy,
has everybody else lost Samson as well?
There's something also we'll be looking at how devices.
Seems you're dropping out a lot, Samson.
Samson, you dropped it. Do you mind typing it in the chat? And I'll just add from a sustainability perspective, I think it's important, that question from Peter as well, that I think it's just all of our responsibilities as individuals. So, and I really do overuse this quote, but with great power comes great responsibility. And we are all part of a puzzle. We are all part of this global ecosystem of technologists, but also global citizens. And I think when we're thinking about technology design and development, considering that without considering the needs of planet and society is irresponsible, and it's part of our responsibility to be considering these kinds of implications through the design, the manufacture, the deployment, usage, and end of life of hardware and software. So I think it's on everyone to take those considerations. And in terms of prioritization, I think there's something to be said for going where you're loved. So we don't need to be trying to solve every single problem on the planet, but where does it most naturally fit? And one of the things that's coming through thick and fast in the trends watches that we're doing from a sustainability perspective, that investors are looking at, that governments, partners, customers are looking for, is a transition to a circular economy. So what does that mean to devices? What does that mean to life cycles? So how do we consider whatever piece of that puzzle we're working in, what the sustainability implications are for that product, for its application, and for its end of life? Sorry, Samson, if you're back, jump in.
Oh, it's okay. Thank you. I hope I am back. I think I had some slight disconnection. Yeah, so I was, yes. Before I was talking about having to, in the aspect of dealing also with the energy issues and prolonging the lives of the devices. If you can, let's have different devices, and then as they collect data, then they also learn more using tinyML. Then once a device has been able to learn more, then the new model can be shared amongst the other devices through federated learning and some of these techniques. I think that can also help improve in prolonging the lives, other than sharing data to a certain point, and then you have again to deploy models back to the devices.
Let's go. Yeah. One thing that I'd like to make, like one of the first things that Fran said, if you're currently an entrepreneur, you work in a company and you haven't heard about this, there's the responsible AI license, which kind of, if you're building something that developers use or that end customers use, take a look at it. I think it's really interesting, and there's a lot of good stuff that you can do with tinyML. There's a lot of bad stuff that you can do with tinyML, both for not just for the planet, but also to other fellow human beings. So consider that. Like, we actually enforce it for all our projects. We don't work with customers that we think are not going to rely on that. So that would be a good first step if you're a platform or a company, and you actually want to prohibit that in a legal way.
And Gian, there's a few questions for you in the chat. if you want to take a look at them.
I will do that. Do you want me to answer them here or just type it out?
Yeah, just go. You can answer them here, and I think we're getting ready to wrap up. So if you take that,
okay, I'll answer it on the Q&A actually, because it's not related to tinyML for good so much. So
okay,
we don't divert so much.
Okay. So with anybody else on the call, I think we're going to hand back to Evgeny very shortly. If you have any questions for the panel, please.
Yeah, I do, Fran, and I think that was actually the one that Peter asked, and I was about to ask this question too. There are so many things we can do together, but if you look at this thing overly, are there any specific areas where we as a community could make the biggest impact? I mean, there are like 17 goals, healthcare, climate, those things. What will be the best way for us to channel our energy kind of collectively? I mean, there are some logistics questions like what Gian asked, like getting the hardware, improving supply chain, this, but specifically talking about the goals, I'm sure, Fran, you kind of, and your colleagues think about this like every day, every minute, like where we should channel our energy to have the biggest impact.
Yeah, I've had many different thoughts about this. I'd like to hear from the rest of the panel what they think as well, potentially Ciira and Tomas particularly on on energy efficiency.
Right. Especially in the near term, because we have, nobody has doubts. I mean, tinyML and ML in general is going to have a big impact. But if you talk about like near term, like a year, 2 years.
Yeah, I think it's in terms of filtering it down, because there's so many different areas and so many different applications that you could work on. But I think it starts with looking at the big picture, like we've shown in terms of the global goals, looking at what's the most important, and really the most urgent challenge right now is the climate crisis. So what can we do to unblock that? And part of the issue from the tech sector is that through consumer products and devices and communications networks, the ICT industry as a whole is predicted to be contributing up to 50% of the world's electricity requirements by 2050. So if we're on that kind of a trajectory in terms of energy requirements, device access, all of these things that we're making more things. There's the two interlinked challenges, I think, of a transition to a circular economy. So what does that mean, and what implications does that have for e-waste? But then also energy efficiency and how compute power relates to carbon and the world's net zero carbon targets by 2050. So it doesn't seem that immediate. It's not like the next 1 to 2 years that you're talking about, but I think you start from the net zero carbon global targets, and that's not, I think it's a misleading term, and I've read about this a fair bit, that net zero carbon sounds quite small because it's got zero in it, but actually it's 51 billion tons of carbon that we produce every year that we need to stop producing, whether that's in manufacturing products, buildings, whether it's in electricity, whether it's in transportation. How can tinyML feed into solving the challenges of those industries? So I think the prioritization in my mind, this is me speaking as an individual, would go from global need, climate, the top 5 areas that can have the biggest impact, and the things that we can do as a community that address those challenges within those industries.
No, I think it would be good to develop like a white paper document that we can distribute to the whole community, kind of like a roadmap effectively, right? So kind of people can think about this thing. I think that would be good. But related to your comment you made on the carbon, I think I have a joke, but it could be a serious joke. Like if you could make all the governments in the world tinyML mandatory, so that would drive a carbon by like a factor of 1,000, right? I mean, there was a paper by MIT published last year. They basically show if you train your models for tinyML compared to the CloudML, it's 1,000x less energy consumption just to train your model, right? So, and I mean, companies like Edge Impulse and others, they train amazing models like with little data, and it doesn't really consume tons of server and cloud space. So I think that would have massive impact. I'm kind of said semi-joking, but I mean, seriously speaking, that could have a big impact like right away.
Yeah, and that's actually interesting in terms of different regions around the world where people are coming online, the next billions around the world that are connecting. If you don't have a connection, you don't have access to information, to choice, to opportunity, to other things that other people do. And so as that connection is being established, how can you design with sustainability in mind rather than retrofitting or backdating or remotely updating things that weren't fit for purpose in the first place? So I think there's different considerations for, as Ciira mentioned earlier, situational or context appropriate solutions dependent on where you are and what you're looking at. I think Ciira, you trying to jump in there?
Yeah, just in terms of prioritizing, I think actually the issue of capacity building and training is actually like multiplies, because here's the thing, we are seeing that there's a lot to be done. How you end up, I think, doing a lot is trying to get more people doing the stuff. So I think it's like what's happening at the Center of Excellence in Rwanda. Now you see we have 3 people from that on this call, all doing one in agriculture and, in health, other, and, water. So there you go. Those are already three of the, I don't know, you'll probably kill me for not knowing how many they are. But you see, so I think if we can do a lot more capacity building within the community, you can end up, having a lot of people working on these problems. And I think personally, maybe it's because I'm a lecturer, that's what I'm really passionate about, is making sure a lot more people are able to build things. And I think Gian maybe is also may also back me up.
No, I think
maybe.
I think getting people, I think people getting their hands dirty is key. It's like, for me, I think for me, the way that I would describe my journey into tinyML, the first time that I had a model that actually did something, it made me just as enthusiastic as I was the first time that I typed my name in my computer in 1998 and the computer said back, "Hello, Jan," in a message box in VB6. And once you feel that power, all of a sudden you're going from your mind, like it explodes, right? It sees all these connections and stuff where you can all of a sudden tie stuff in, and getting that kind of, sparking that type of creativity is fucking awesome. And I think that's something we can do as a community, wider, not in Africa, but wider in the whole world. And I think that's the thing that makes me most excited to be in this space.
And is there any final thoughts?
Just something else to chip in. Okay, on the same, I think also something that is important that has also helped us at the African Center of Excellence is being able to share what you have done. And I'm very happy that most presentations that have been going on, people are sharing, saying it's available, you can be able to try out on this. So after somebody has taken months to do something and then share, I come in after a few months to something that somebody else has been working on, it takes a short time to replicate the same as compared to starting from where the person had started. So this culture of being able to share as a tinyML community, I think is something that is good and that can also help us to improve on the same.
Yeah, great. So maybe, Fran, maybe we can conclude something like a call to action. I mean, I've been absorbing this discussion. It's been really a great discussion. I mean, from all over the world, and people sharing their experience and their success stories. I mean, my take from this discussion was first kind of do more education, educate more people, build bigger community, give them more technology tools, software tools, hardware tools, simplify logistics, and focus on climate change type of problems. Is it the right kind of summary? Kind of, did I get it right from this 1 hour discussion? I mean, that's what we should take away as the community from this and kind of go from there.
I think that's a good takeout.
Yeah, I think also that summarizes pretty well. So I had a think before the session also on important things, and maybe I could just add one thing, and that is the answer to the question, why is this important? And I think we touched on it here, and that is because it's here and now, right? It's not, tinyML is everywhere. It's in each one's hand, in the phone, listening to us. And so I think the ethics of tinyML, we didn't touch much upon it. The security and privacy in something that is something we as a community we need to strive for that being for good, being for privacy, and sort of, because it's here and now, right? And actually us as a community also informing the wider community about the fact that there are now sensors everywhere that are listening in, and many of them are actually sending data to the cloud, etc. Currently, and just make people aware of tinyML. It's here and now, and you know, it's important, and it has an impact, and we need to make sure it's for good. But we, okay, I know it was a bit late in the discussion, but I think that's an important topic as well. So we can talk about this forever, I guess.
Next panel.
Next panel, maybe. Yeah.
And just to have a short announcement before we conclude, I think at the tinyML Foundation, we recognize this. We had a kickoff at the summit. I think we formed a small working group, tinyML for Good. And there is an email list for good at tinyml.org. And this working group is chaired by Kate Kellett. I mean, she's very well known in this community from the ARM days, Intel days, and now NVIDIA days. I mean, she's super passionate about this. So I think we are going to be starting projects in this area. That's why I think this kind of funnel process is important, because I think we'd like to bring more funding and more kind of process into this, and we have the whole global community of thousands of people. And I think another thing what we decided to list at this working group, and I'm kind of speaking to Kate, to have a dedicated workshop, tinyML for Good workshop sometime in the fall, so where we can kind of take this discussion to the next level. Kind of just a short announcement, but really try to do very practical, very tangible things, because we have a big community. People are very passionate. The technology is there, the tools are there. We just need to kind of collectively start doing things. Not, I mean, this panel is great, but I think we want to do more than panel. We want to get our hands dirty and do make a difference there. That's what I would love to see more and more coming in the next months. So any concluding comments? Or yeah. I think we are already kind of at. Yeah. No, the opportunities are huge. I mean, there are so many good things that can be done. Absolutely. And I think we're seeing that today with a lot of good examples. So. Yeah, no, I think we'll probably continue the discussion and more kind of at the project level. But I think I would like to thank Fran for putting together this amazing session. Thank you, ARM, for being so active in this field, and also for sponsoring the technical forum. Thank you, all the panelists. I think this panel is just the beginning of a journey. I think, like what Elad said, it's a journey. It never ends. But I do feel that this community has a lot of energy and a lot of talent, and ready to make big changes in this world. And the tinyML is actually a great technology for this. It's a great tool.
Of course, I do want to thank all our sponsors. So the premier sponsor, Newton, with their automated tinyML solutions. Executive sponsors, ARM, and we organized also a very nice panel that we witnessed just now. Edge Impulse as well. Jan was there and presented some of their work just now as well. Then also Qualcomm, working on advancing AI research to make efficient AI ubiquitous. Sentient, working on chip solutions to do ultra low power, high performance, deep neural network processors. Then our platinum sponsors, Infineon. We've had a keynote from Wolfgang from Infineon earlier today. Reality AI, working on advanced sensing with Edge AI and tinyML. Then our gold sponsors, Latent AI, working on adaptive AI for the intelligent edge. SensiML, building smart IoT sensor devices from data. And then our silver sponsors, EMSA, where Elad also presented today what they are up to, Green Waves Technologies, HOTG, Imagimop, KISO, SEED, and ST. And with that, that's the wrap for today. Thank you everyone for your attention and your attendance.